video, we want to look at limit. Okay, I am going to list all the techniques that we can use to evaluate questions in limit. Okay, we have 4 of them. Then after, we now use all these techniques to solve questions. So the first one is what we call direct substitution. So let us list the techniques out. The techniques that we're going to be using to solve questions under what limit. The first one, we call it direct substitution what method. Direct substitution method. Direct substitution method. Okay. Second one is what we call factorization method. Factorization method. We have the third one that we call L'Hopital's rule. L'Hopital's rule. L'Hopital's rule. Then we have the fourth one that we call rationalization by rationalization using conjugates. Using conjugates. Okay, so these are all the techniques we're going to be using to evaluate questions under limits. The first one, like I said, is direct substitution. So it means any question given under limit, the first thing to do is to solve the question using direct substitution. If or when direct substitution now fails, we can now use what now? Other methods. And class C. It is important, okay, to know all these methods, but it's far important to know which of these formula or to know when to apply any of these formulas to solve a question. We can know the formulas, okay, but which one can we use to solve a question? That one is very what now? Very important. So let us go and solve questions using all these techniques. Okay, I'm going to solve questions using all these techniques. Okay, so let us go. The first one, we have to what now? Evaluate. Look at this question. So let me divide the board into 2. So we have to evaluate lim as s tends to 2 or s approaches 2 of the function 2x squared plus 5x plus what now? Plus 5. What's the meaning of this, class? It means anywhere we see x, we just substitute what now? 2. Like I told you, the first thing to do is what now? You use what now? Direct substitution. So here, what will be our solution? So we have the lim as s tends to 2 or s approaches 2 of the function 2x squared plus 5x plus 5 becomes 2 brackets 2 squared plus 5 bracket what now? 2 plus what now? Plus 5. So what do we have here? 2 raised to the power 2 is what now? Is 4. 4 times these 2 give us what now? Give us 8 plus 2 times 5 is what? Is 10. Then plus what now? Plus 5. So 8 plus 10 is what now? Is 18. 18 plus 5 will give us what now? 20 what? 23. So the answer to this question is 23. What do we use here? We use direct substitution. Are you with me now? Like I told you, it is when direct substitution fails, we're going to use what now? Other what now? Suitable method. But I will tell you when to use other method. And I will tell you when to know that direct substitution cannot work now, cannot work. So let us take another question. So we have evaluate the lim as f approaches what now? 1 of the function 2x plus what? 5 all over s plus what now? 3. What's the rule? Direct substitution first. Direct. So solution. So we have the lim as s tends to what now? 1 of 2x plus 5 all over s plus 3 will give us what now? 2 bracket what? 1 plus 5 all over 1 plus what now? Plus 3. So what do we have here? 2 times 1, 2 plus 5 all over 1 plus what now? 3. So what do we have here? 7 over what now? Over 4. So the answer to this question is what? Is 7 over 4. Now look at this question. Look at this. We also evaluate lim. So also evaluate lim as s approaches what now? 2 of the function s squared plus 4 all over x minus 2. Okay, now class, I told you the first thing to do is what now? Use direct substitution. Now, if you see a question that involves fraction, if after direct substitution, our denominator now gives what now? With 0, it means that direct substitution will not work. It means it fails in that what now situation. I repeat, anytime you see a question that involves fraction, like this one over here, this is a fractional question, then after direct substitution, you see that when we use direct substitution, the limit of what now? Let's see, as x approaches 2, we're having 2 raised to power what now? 2 minus what? Minus 4, all over what now? 2 minus 2, which will give us what now? 0 over what now? 0. I'm less concerned about this one. Okay? Once the denominator gives is 0, then it means what? We cannot use what now? Direct substitution. We cannot use other what now? Other method. So here, I can use what now? I can use factorization method. I repeat, please class, take note. I'm laying more emphasis on this. Once we use direct substitution and our denominator is 0, we now use what? So it means this one cannot work because this one is what now? Undefined. This one is undefined. So what I'm going to do, I'll now use what now? Factorization method. I'll use factorization method. So it means our limit of what now? Of limit of s squared minus 4 all over s minus 2 as s approaches 2 will now give us what now? This is the difference of two squares. So we have s squared minus 2 squared all over s minus what now? S minus 2. That is the limit as s approaches what now? 2. So what do we have here? Factorize this, we got s minus 2, s plus 2 all over s minus 2. So what happens? S minus 2 will cancel what now? S minus 2 will now have what now? S plus what now? S plus 2. It means we're having the limit of what now? S plus 2 as s approaches what now? 2. We cannot put our what now? Our 2 here. We can use the direct substitution now. So that will now be what now? 2 plus 2, which gives us what now? 4. So the answer to this one is what now? Is 4. I told you, it is when we use direct substitution for a fractional question and our denominator is what now? Is 0. That's when we use what now? Factorization what now? Method. Look at this one. Look at this question. So you understand what I'm trying to say here. We also evaluate the limit as s approaches what now? Is 0 of the function 2x. Let's just use 3x plus 4 all over 3x minus 4, 3x minus 12, 3x minus 12 all over x plus 3. Let's use as s approaches what now? 4. Now look at this. Look at this. So the first thing is direct substitution. So we have, okay, the limit of what now? Of 3x minus 12 all over x plus 3 as s approaches what now? 4. We're having what now? 3 bracket what now? 4 minus 12 all over 4 plus what now? Plus 3. This will give us what now? 12 minus 12 all over what now? All over 7, which is what? Is 0 over what now? 7. Our answer here is what? Is 0. Is 0 over anything will give us what now? Is 0. But anything over 0 is what now? Undefined. This one now is correct. Are you with me now? That nature does not affect the numerator. Okay? That is 0 will only affect what now? Denominator. When we use direct substitution method and our numerator is what? Is 0. And we have what now? A value here. It could be any value. It could be 1, it could be 10, it could be any value. Our answer because what now? Is 0. But when we use direct substitution and our denominator here is what? Is 0. So it means in this case, that direct substitution method what has failed. Okay? So we now use what now? Factorization what? Method, or we will call L'Hopital rule. Okay? Another rule, okay? We can use L'Hopital to solve all the questions. Are you with me now? We can use L'Hopital to solve all the questions. Are you with me now? So now look at this. Let's have more questions. Let me use L'Hopital for this. The second question. Let me just quickly introduce also what we call L'Hopital rule. Because I love the rule. I love the rule. That's what I use to solve what now? Questions under what limits. So L'Hopital says, L'Hopital rule says we just differentiate the up. When question involves what? Fraction. We differentiate what we have on top. We differentiate what we have below before we now use what we call direct substitution. Like look at this. For that example that we had, x squared minus 4 all over x minus what now? X minus 2 as s approaches what now? 2. Okay. Now, if I want to use L'Hopital says differentiate what you have on top, differentiate what you have below before you now what now? Substitute. So let me quickly introduce us to what we call differentiation. After this topic, we are moving to what we call calculus. Are you with me now? Which is what now? Differentiation and integration. So if I want to differentiate, if I'm having y is equals to a s raised to power what now? N. Our dy dx, okay, will be equals to, I will use this power here to multiply what now? The coefficient. It will now be a times n. It will be a times n. I'll write this s back, x. I will now subtract 1 from this n. That will be what now? N minus what now? Minus 1. For example, if I have y is equals to 3x raised to power what now? 4. What's our dy dx? I mean to differentiate. It will be 4 times 3 or 3 times 4. So I have 3 times 4. If I'm using what now? The power rule. We call it power rule or general formula. So 3 times 4. Then I'll write my s back. I'm now subtract 1 from what now? From this. Okay? This will now be equals to what now? 12x raised to the power of what now? Of 3. So we are going to be using this concept here under L'Hopital rule. We are going to what now? Differentiate what we have on top. Differentiate what we have below. We now what now? Substitute. So what do I have here? If I want to use L'Hopital, I'm using what now? L'Hopital's rule. So we have, if I'm asked to differentiate this one, this will give us 4x. When I ask to differentiate a constant, if y is a constant k, then the y dx will give us what now? Is 0. If I ask to differentiate a constant, our answer will give us what now? Is 0. This is a constant. Okay? This is also what now? A constant. So I will differentiate s squared minus what now? Minus 4. It means here, look at this. I'm having y equals to what now? S squared. If I use this formula, our dy dx, okay, will be equals to what? This is 1 here. I'm having 1 times 2. Then s raised to power what now? 2 minus what? Minus 1. We'll now be having what now? 2x raised to power what now? 1. S raised to power 1 is what? Is x. So our answer here is what now? Is 2x. A constant. If I also differentiate the constant, answer is what now? Is 0. So here, we're having 2, okay, x all over 2x. So here, we have 2x all over. Now, differentiate the x. So if I have y equals to what? Look at this. Y equals to what now? X. What is y divided dx? It will be equals to, we have 1 here. 1 times 1. So we have 1 times 1. S raised to power what now? 1 minus 1. This is the general formula here. So this will now be equals to what? 1. S raised to power what now? 0. What is s raised to power 0? That is 1. So I'm having 1 times 1, which gives us what now? 1. So if I differentiate s minus 2, okay, our answer will be equals to what now? 1. Because this is a constant. When you ask to differentiate a constant, we have what now? Is 0. So our answer is what? 2s all over 1, which will give us what now? 2s. I cannot substitute directly. Our s is what? This is 2. We are having 2 bracket what? 2, which will give us what now? Which will give us 4. Okay, answer to that question is 4. So I can use that substitution. I can use what now? Factorization. I can equally use what we call L'Hopital rule. Other rules, once you use this one, no problem. So let's have more questions. We also evaluate the limb. Look at this. The limb. So the choice is yours now to use any rule that you like. Okay. So evaluate the limb of s cubed. Evaluate the limb of s cubed minus 27 all over s minus what now? S minus 3. S minus 3 as s tends to what now? 3. Class, what's the first thing? What's the first thing to do? We use direct substitution. So when I put 3 here, you see it? 3 minus 3 is what now? Is 0. So it means I cannot use what now? Direct again. It will not work there. Because our denominator is now what now? Is 0. So what will I do? I will now proceed to what now? Factorization. Anytime I have a cube minus b cube, we call this one what now? Difference of 2 cube. What's our result here? It will be a minus b in one bracket. Are you with me? Bracket a squared plus ab plus b squared. So if I also factorize this will be our what now? Our answer. This is what we call difference of 2 cubes. But when I have the sum, like for example, I have a cube plus b cube. Our answer here will be a plus b in one bracket, open bracket, a squared minus ab plus b squared. So sum of two cubes, difference of two cubes, sum of two cubes, difference of two cubes. What about if it is now squared? So if I have a squared minus b squared, this is what we call difference of two squares. Are you with me? Our answer here will be equal to what now? A minus b in one bracket, then a plus b in the other bracket. What if now sum of two squares? If I have a squared plus b squared, our answer here will be equal to what now? A plus b all squared minus 2ab. Take note of this what now? Expansions, okay? They are standard what now? Expansion. And note again, note that what? A minus b is the same as minus b minus what now? A. Take note of this. It's very, very important. A minus b is the same as saying what now? Minus, open bracket, what now? B minus. So let me just what? Prove this now. Suppose our A is 10. I'm having 10 minus, suppose our B is what? Is 4. So what is 10 minus 4? 10 minus 4 will give us what now? 6. Will it be the same as this? Okay, so will it be the same as minus, open bracket? Our B is now 4. So we put what here? 4 minus, what's our A? Our A is 10. So 4 minus what now? Minus 10. So here we have minus bracket. What is 4 minus 10? That is minus 6. So I have minus 6 here. Okay, minus times minus will give us what now? Plus. We have plus. So it implies that this thing is very correct. A minus B is the same thing as saying what now? Minus open bracket B minus. We're going to see that in what now? In the next question here. But let us solve this. Let's solve this class. So, alright. Direct cannot work here. I think you know the reason, because this one gives us what is 0. So we now what now? We now factorize. Limit of s approaches what now? 3 of s cubed minus 27 all over s minus 3 is same as saying what now? The limit of s approaches what now? 3 of s cubed minus what? 3 cubed. 3 cubed is 3 times 3 times 3, which is what now? 27. 3 times 3 is what? Is 9. 9 times 3 is what now? Is 27. Then all over what now? X minus what? X minus 3. So I will now use this one. Difference of two cubes. You see it? So now be the limit of, as s approaches what now? 3 of x minus 3, one bracket, open bracket, s squared, then plus a times b, that is s times 3, that is what now? 3x, then plus what now? B squared. Our b is now what? Is 3. What is 3 squared? That is what now? 9. So 9 here. Then all over what now? S minus what? S minus 3. Can something? Yes. S minus 3 can cancel what now? S minus 3. So now we are having the limit as s approaches what now? 3 of s squared plus 3s plus what now? Plus now. I can now use what we call direct substitution. This will give us what now? 3 squared plus 3 bracket 3 plus 9. What is 3 squared? 9 plus 3 times 3, 9 plus 9. So 9 plus 9, 18. 18 plus 9 is what now? Is 27. So the answer to this question is what now? Is 27. Okay? Using this what now? Standard what now? Factorization. Let us solve one jam question. 2021. 2021 is the question. So please, just you can pause the video and write these formulas down. Okay? So you can pause the video and write the formulas down. So let me solve jam question. 2021. Okay, jam question 2021. Jam. But as for what now? The limit of the second says the limit of x squared minus a squared all over x minus a as s tends to a. As s tends to a. Tends to a is so yeah, look at this now. We are saying the limit of what now? Of s squared minus a squared all over s minus a as s approaches a or s tends to a. If I use direct substitution, this will be a minus a, which is 0. So it can't work. So now you know what we call what now? Factorization method. So this one will now become the lim of s minus a, difference of two squares, you see it? Bracket what now? S plus a all over what now? S minus a, as s approaches what now? A. So what happened? S minus a will cancel what now? S minus a will now have the lim of s plus a as s approaches what now? A. Can I use what now? Direct substitution. So this will now be a plus a, which will give us what now? 2a. 2a. Okay, so let's solve this question. So we have plenty of questions to solve. Okay, so look at this. Look at this question. Let me wipe this one off. Let me wipe this one off. So the more question we solve, the more you understand the concept of what now? Limit. So we also evaluate. Okay, lim. Look at this. Lim as s tends to 2 of 1 over x minus 1 over 2 all over s minus what now? S minus 2. Look at this. If I use direct substitution method here, it will be undefined. Our answer will be undefined because this will give us what now? 2 minus 2 is 0. What are we going to do? First, let us solve this one. This is a fraction. Let us solve this one. This is a fraction on top. So I'm having 1 minus x minus 1 over what now? 2. What's the LCM? This will give us what now? 2x. How many x can we see in 2x? That is 2. 2 times 1 will give us what now? 2 minus. How many 2 can we see in 2x? That is what now? X. S and 1 will give us what now? X. So it means our answer to this one is what now? The lim of, as x approaches what now? 2 of 2 minus x all over 2x divided by x minus what now? X minus 2, which is the same as saying the lim as x approaches what now? 2 of 2 minus x all over 2x times 1 all over what now? S minus 2. Now, what are we going to do here? Look at this very well. You see that I said if I have a minus b is the same as minus b minus what now? A. So I will now change this one here. Are you with me? I will change this one here by this what now? Minus. So I'm having the lim of what now? S approaches what now? 2 of minus s minus 2. Look at this. Look at this. A minus b equals what? Minus b minus a. So I'm having 2 minus s. The same as saying what now? Minus open bracket s minus 2. Then all over what now? 2x times what now? 1 over what now? S minus what now? Look at, see, mathematics, you can what now? Maneuver your ways. You manipulate some what now? Some areas in mathematics, okay, to suit what you want to what now? To solve. This one does not suit what I want to solve. But what I do? I have to manipulate using this standard what now? Concepts. So now, very clear. Okay, so this one cancels out this. Now we're having what now? Minus 1 all over 2x. That is the lim. The lim as s tends to what now? 2 of minus 1 all over what now? 2x. I cannot use what? Direct substitution. I cannot put what here? I can put 2 here. You see that? So now because what now? Minus 1 all over what? 2 bracket what? 2. So because what? Minus 1 all over 4. I hope you are getting what I'm doing. Okay, so I use this concept here to solve this what now? This question. So let's solve more questions before we call it what now? Again. Now look at this. We also evaluate the lim of root of x plus 13 plus 2. Alright. So let me wipe this one off. So evaluate the lim of what now? Lim as s tends to 3 root of s plus 13 plus 2 outside all over s plus what now? S plus 3. So what are you going to do here? Use the substitution method. That's the first thing. So here we have solution. That will be the lim of, as s approaches what now? 3. The root of what now? 3 plus 13 plus 2 outside all over 3 plus what now? 3. This will be root of 16 plus what? 2 all over what now? All over 6. Okay? What's root of 16? That is 4. So I'm having 4 plus 2 all over what now? 6. That is what now? 6 over 6 and answer equals to what now? 1. Direct is very sweet. Okay, so just substitute direct, then you get your answer. But if it fails, then use other what now? Other method. So let me solve one more question. I'll now give us question to what now? To solve. Please make sure you solve the question and put it in the comment section below. Okay, give the answer to the question that I will give you after this video in the comment section below. Now look at this. We have to evaluate the limb. Evaluate the limb of root of x minus 2 all over x minus 4. Evaluate limb of root of x minus 2 all over x minus what now? 4. As x approaches what now? 4. Okay? Here, what are we going to do? If I put 4 here, 4 minus 4 by direct is 0, so I can't use that. What will I do, class? I will use what we call L'Hopital rule. L'Hopital is very strong, please. Very, very important. So please make sure you understand what now? L'Hopital. What is L'Hopital? Differentiate what you have on top, differentiate what you have below before you know what now. So I have taught you those simple aspects of what now are differentiation. Are you with me? So here, the root of x is the same as saying x raised to power what now? 1 over 2. Okay, in index form, root of x is what now? X raised to power 1 over 2. Cube root of x in index form is x raised to power what now? 1 over what now? 3. Before I can differentiate, I must have power. So it means this one here is the same as saying what now? The limit of as x approaches what now? 4, x raised to power what? 1 over 2 minus 2 all over x minus what now? 4. I cannot differentiate this one. It will be, look at this, 1 over 2. I think you know that the power will come down as 1 times. Let me do it so you understand what I'm saying. So it will be 1 times, this one is what? Is 1. Coefficient is 1 here. So we have 1 times 1 over 2, which is the power. Then I'll write x back. I'll now subtract 1 from this one. Okay. Then this is a constant. If I'm asked to differentiate a constant, answer is what now? Is 0. So I'm having this on top, then all over. If I differentiate x, I'll have what now? 1. Differentiate minus 4 is 0 because it is a constant. So here I'm having 1 times 2, 1 times half, I'm having half. Then x raised to power half minus 1 is minus what? Minus half. Are you with me? Now, can I do anything here? Yes, I cannot put the what now? The 4 here. Are you with me? I can put my 4. This one is 1 over 2 times x raised to power minus 1 over 2. So I'm having 1 over 2 times what is now our x? That is 4. So I'm having 4 raised to power what now? Minus 1 over what now? 1 over 2. Let me solve this one from indices. See that mathematics, they are interwoven. The topics are interwoven. This is what now? Index expression. So let me solve this one separately. 4 raised to power minus half. Same as saying what now? 2 raised to power 2, which is 4. Then times what now? Minus 1 over what now? Over 2. These two will cancel out these two. We now have what now? 2 raised to power what? Minus 1. If I have a raised to power minus x, okay, that what we call negative power rule. That will be 1 all over a raised to power what now? X. So this one become 1 over 2 raised to power what? 1. What is 2 raised to power 1? That is 1. So I have what? 1 over what here? 2. So this one is the same as saying what? 1 over 2 times what? 1 over 2. And our final answer will be equal to what? 1 over what now? 1 over 4. Class. So you can just rewatch the videos, okay? All the videos that we have on what now? On mathematics, you watch them under limit. Are you with me? So I'm going to give you what now? Some questions here, which you must. No. Let me solve one more question, which is very, very important. Then after that question, I will now give you what now? Question to attempt. This question I want to solve is very, very important. So now pause the video to see the solution before I clean the board. Okay, we have to evaluate the limit of what? 5x cubed. Evaluate the limit of 5x cubed. Evaluate the limit of 5x cubed. Limit of 5x cubed. Evaluate the limit of 5x cubed plus 3x minus 1 all over 3x cubed minus 4x plus 9 as x tends to what now? Infinity. Okay? So whenever it's a question like this, you divide through by what now? The highest power of x. Once a question like this, involves what now? Infinity. Are you with me? This is symbol for what now? Infinity. We divide by the highest power of what now? Of x. What is the highest power of x here? This is x raised to power what now? 3. So we now have solution. We're having the limit of what now? As x approaches what? Infinity of 5x cubed all over x cubed. I will divide everything through out by x raised to power 3. Then plus what? 3x all over what? X cubed. Minus all over what now? S cubed. Okay? Then all over 3x cubed over x cubed minus 4x over x cubed plus 9 over what now? S cubed. So what do I have here? X cubed cancel x cubed. I'm having what? The limit of x approaches what now? Infinity of 5 plus 3 over s squared, because 1x here will cancel 1x here, our s squared. And all over what now? S cubed all over 3 will be here minus 4 all over what now? S squared plus 9 over what now? S what? S cubed. I can now put in my what now? My infinity what now? Symbol. Okay? Using that what now? Substitution. This will now be 5 plus what? 3 all over what? S infinity squared minus 1 over what now? Infinity cube. Then all over 3 minus 4 all over what now? Infinity squared plus 9 over what now? Infinity what now? Cube. Anything over infinity is 0. Take note. Note. A over infinity give us what now? Is 0. Even if you have A over infinity squared is 0. A over infinity cube is 0. Everything now. So everything will give us what now? So here 0 is 0 is 0 and what now is 0. So our final answer here is what now? 5 all over what? 5 all over 3. So when the question involves what now? Infinity. When our x is approaching infinity, we solve it like this. This is the format. Okay, so we divide by the highest power of what? Of x, which is in this case x raised to power what now? X raised to power 3. So class, let me now give us some question to solve. You can drop your answer in the comment section below. Yes. So we have just 3 questions. 3 questions I want to give. The first one, so I'm going to evaluate the limit of all these. Evaluate the first one, the limit of s squared minus 25 all over s squared minus 10x plus 25. That's the first one. As s approaches or s tends to 5. That's the first question. Second question, we have to evaluate the limit as s tends to 2 of s plus 2 all over s squared minus x minus 6. I think we're okay with this. So the first one is, you see it? When you put 5 here, 5 squared, 25 plus 25, 50. Minus 10 times 5, that is minus 50. So 50 minus 50 is 0. So I can use what now? Direct here. I'll use what we call factorization. This one 2, the same thing. But you put 2 here, this will be 4. 4, this should be minus 2, not 2. Sorry, it should be minus 2, not 2. Let's put minus 2. As s approaches what now? Minus 2. As s approaches minus 2, this will now be what? 4 plus 2 minus 6. That will be 4 plus 2, 6. 6 minus 6 is 0. So just solve it and put the solution in the comment section below. So class, please help us to do more. Okay, we are asking you to help New Teacher to grow. Support New Teacher financially. You can see the what now? The account to pay in. No amount is too small. Okay, help us to do more. We want to produce more videos, but we need financial support. So we are asking you, our viewers and our subscribers, to help us to do more. Let's New Teacher grow, please. So we are asking financial support from our viewers and our subscribers. So you can see any of the account, either here or here. We'll drop the account to pay in either here or here. Please, no amount is too small. Thank you very much. God bless you.